We will see machine learning challenges and the possible solutions for them. So let's start. I will explain these challenges under two titles, data and algorithm, because some of them are directly related with data but others are related with algorithm or design. So let's start with data-related challenges. First one is insufficient quantity of training data. As I said in the previous sessions, one of the most important elements of machine learning is data, but this data should be enough, sufficient. And machines are not like humans. They cannot learn something from a few pictures, for example. If I show this picture to a child who doesn't know the apple, he or she can understand other apples mostly. But machine learning needs more data. For example, let's think the image classification example. Models should be trained with various apple images, different colors, perspectives, lights. Otherwise, machine learning cannot learn to detect apple. And it can easily fail in, let's say, tomato images or cherries. Solution is feeding the system with sufficient data. There is no general and exact number to measure this sufficiency. It depends on the project, but generally they need over hundreds of thousands training data, sometimes over millions. Second data-related challenge is non-representative training data. Let's look at the graph. If you ignore the examples like Brazil, Mexico, and Chile, then your model will be wrong, or we can say less representative. As you see, after adding the red ones, model should be updated. This is quite important topic as sampling bias is also possible. For example, in 1936, Literary Digest tried to make a survey to estimate the US presidential election. However, their survey population is not representative and they could not estimate the election in the right way. So you can search the details of that event. And I want to give more recent example. Some researchers estimated German federal election in 2009 based on Twitter data. Also same in Irish general elections in 2011. But do you think this works for USA too? Of course not, because Twitter user profiles don't represent the USA general population exactly. These studies show that Twitter users are younger, more highly educated and wealthier than general public of USA. If you just take Twitter data to build an estimation machine learning model, even if your algorithm and all other components are perfect, you cannot estimate the election correctly. So training data should represent this data. And another challenge is poor quality data. In real-world data, there will be so much noise, some outliers. Therefore, if you build a training data set from the real world, you should be careful about the outliers. You can clean these outliers to determine your best model. As you see in the left graph, purple ones are outliers. They should be cleaned. Also, your data may have missing values. Think that you made a survey manually and some people doesn't give all answers. Like in this table, some values can be missing in your data set. Dealing with missing values is another topic that we can discuss, but briefly, I can say that a couple of strategies are available for that. One can be filling the missing values based on other inputs. For example, in first row, weight is missing. You can calculate the average of others and fill the first row with that value. However, you can easily see that this is not good for this dataset because there is a correlation between the sex and the weight. Weights of males explicitly higher than females. That's why calculating the average of only males for the first row makes sense. Another strategy, deleting unrelated examples or features. For this example, if the marital status is not related with your project, you should delete it. If you have enough data, you can delete the ones have missing values. Of course, these are trade-offs. You should be careful about that. But don't forget that garbage in, garbage out. This is a quite popular principle. By the way, another challenge is irrelevant features. Feature set is vital. With feature engineering techniques, feature selection, extraction, or creating a new feature will be important phases in your project. Each of them is very important and long topic. For now, I skip feature selection, extraction, and details. One of the most popular terms in machine learning is probably overfitting, and this is another challenge in machine learning. Overfitting means that your model overgeneralizes or memorizes the training data. Think that your model memorized the cats have 2 ears, and when you give an image of cat with 1 ear, model classify it as non-cat. Overfitting can be possible especially when the model is too complex or training data set is too noisy. Let's look at the graph. This is a life satisfaction and GRP per capita graph, and if you added the country names to your model can think countries which have W in their names have greater life satisfaction because of Norway, Switzerland, and or Luxembourg. But do you think that it's logical? Of course not. What about Rwanda, Zimbabwe? There is no correlation between the name and the life satisfaction. Let's look at another example. The graph shows a good model. There are some outliers at the top. However, if the model overfits the training data, the model will be shown as the right one. This is memorization. And the last example for overfitting, think that you have 2 classes as red and blue in your training data set. If model overfit, then it will be like the orange one and misclassify the enemy examples. However, correct model should be like the green curve. Okay, we saw different overfitting examples, then what can be solution ideas for this problem, for the overfitting issue? The first one is simplifying the model. By reducing the number of features, attributes, and constraining the model, you can simplify the model. And the second one, getting more and representative training data. And the third one, reduce the noise, clean the outliers. So this is a regularization, and the regularization is important to prevent overfitting. How can we control the regularization amount? Answer is with hyperparameters. Hyperparameter is a parameter of learning algorithm, not the model. And tuning hyperparameter is an important part of building machine learning. We will see this topic later. Let's look at an example. First model is the dashed blue line. If we add a red example and update our model with all data, then the model will be like the red line. Red ones can be important, but as you see, red line doesn't correspond to blue examples well. This is not the correct model. After some regularization, model will become like the blue bold line. It's better than the dashed one in terms of red examples. But also it represents the blue example better than the red line. I hope you get the main idea. Another challenge, and the last one, is underfitting, just opposite of overfitting. That means model cannot learn. Overfitting is overgeneralizing, memorizing, and this one, underfitting, is insufficient learning. Generally, when the model is too simple, underfitting may be seen. Okay, how can we fix? We should select more powerful models, and we should feed better features to the learning algorithm, and we should reduce the constraints on the model. If you remember, orange one is overfitting example, and the light green line is the underfitting example. As you see, it's not right model for this data set. It's too simple. Okay. Until now, we solved data and algorithm-related challenges and possible solution ideas. In the next section, we will see how to evaluate our machine learning systems. What are the performance measures?